Hello everyone. Through this video we are going to discuss some problem sums on permutations, and for that two theorems are very important. Let's first know these two theorems. Here goes the first theorem. The number of, let us see what it says. The number of permutations of n objects where p objects are of same kind, that means in total we are having n number of objects, out of which we find that there are p number of objects which belong to the same category and the rest are all different. In that case the permutation will be n factorial divided by p factorial. So this is the first important theorem. The next important theorem is just an extension of this first theorem, where we shall be getting several kinds of objects which can be categorized in different categories. So here we find the number of permutations of n objects where p1 objects are of one kind, then p2 objects are of second kind, and that goes on up to pk number of objects where pk objects are of kth kind and the rest are all different kinds of objects. And in that particular situation the total permutation will be n factorial divided by p1 factorial into p2 factorial, that goes on up to pk factorial. So actually what this theorem says, say total of n number of objects we are having, and in this among these n number of objects, say we are finding kinds of objects. Suppose this is the first kind where there are p1 number of objects and they belong to the same category. Similarly there is another kind of objects which belong to the same category, and this is p2. There are p2 number of objects which belong to same category. Similarly we are finding say p3 number of objects which are having same characteristics and belonging to the same group. Similarly say this is an extension up to pk number of objects which is also of same kind. And suppose there are a few number of objects which are all different, they do not belong to any particular kind. In that case this factorial means, with the help of factorial notation we can write a total permutation as n factorial divided by p1 factorial into p2 factorial, that goes on up to pk factorial. So these are the two important theorems for solving the problem sums of this of permutations. So here goes the first question. This is the first question. Actually I am starting with question number 10 of exercise 7.3 of NCERT maths book. So here this is question number 10 of exercise 7.3. In this question we are asked to find out how many of the distinct permutations of the letters of the word Mississippi in which all the four I's do not come together. So it is very clear that from the total number of permutations of the letters of this word we have to subtract that number of permutations, number of distinct permutations of this of the letters of this word in which all the four I's come together, and then the required answer will come. So here in this case I am starting with the solution part. Given word is Mississippi. Here in this word several letters are repeated actually. Mississippi, where there are there are 4 numbers of I's, then 4 numbers of S's, then after 2 numbers of P's, then after 1 number of capital M, means M. So first of all, let us find out, actually we find that this is of the first kind, this is of the second kind, this is of the third kind, and this in this case this is individual, only one individual letter we are getting, that is M. So of course the second theorem will be followed here. So let us check in how many ways this arrangement can be done. First let us write down total number of letters in the word. We can write in this word is equal to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in total we have 11 letters here. Therefore, total number of permutations in which the letters can be arranged. The letters can be arranged. So that formula which we got in the second theorem can be used here. That is, in the numerator part we have to write total number factorial on the total number of objects, that is 11 factorial, divided by 4 factorial, that is for the first kind, then after into 4 factorial, that is for the second kind, into 2 factorial, that is for the third kind, and for M we can write 1 factorial. If we don't write that part, then also there is no problem. So after breaking it up, the result we should get here is 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 factorial. We should stop there at 4 factorial so that it gets cancelled with one of the denominator. 4 factorial, then we can write 4 into 3 into 2 into 1 into, and for this one 2. So 4 factorial gets cancelled. Then after what do we get? 3, 2 ja 6, 2 gets multiplied. Then after 2 gets cancelled. Then 4, 2 ja 8, this 2 gets cancelled here. So if we multiply the rest of the terms, the result we should get as 34650. Then after coming to the main condition, when, let us now find out when all the 4 i's together occur together, then what could be the permutation. When the i's occur together, these can be considered as one letter, or you can say single letter. Therefore total number of letters become from 11 letters. Amongst these 11 letters, total of 11 letters were there. Out of these, 4 letters were 4 i's. So if we consider this 4 i's as single letter, In that case, in total, how many letters do we get? 11 minus 4, it will be 7. 7 plus 1 will be 8. So in total 8 letters we shall be getting here. Then after, total number of permutations, therefore total number of permutations will be equal to 8 factorial divided by 4 factorial into 2 factorial. Then our result will become 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial into 2 into 1. So 4 factorial gets cancelled. Then I get here 4. So after complete multiplication, let us check what do we get. 30, 6 5 ja 30. 30 into 4, it will be 120. 120 into 7, it will be 840. So here, therefore, total number of permutation in which all the i's do not come together will of course be equal to, from the total permutation we need to subtract, from the total permutations, that is 3 4 6 5 0, we have to subtract 840, and our answer here will become 33810. That is the answer here. Now let us come to question number 11. That is the last question of this exercise. Question number 11. In this question, what is said? In how many ways can the letters of the word permutations be arranged if words start with capital P and end with capital S? So in this particular question, it is very clear that the first position should always be fixed for capital P and the last position of the words should always be fixed for capital S. Then again in the second question, what is said? All the vowels of this word should come together. In that case, how many such permutations we shall be getting, that we have to find out. And in the third case, there are always 4 letters between P and S, means whatever the position for P and S we get in this words, we must be very sure about the fact that always there should be 4 letters in between P and S. So let's come to the solution part here. Proceeding with the solution. Given word is permutations. Let us first count the letters. How many letters are here? 1 2 3 4 5 6 7 8 9 10 11 12. There are 12 letters we find here. So we can write total number of letters is equal to 12, where number of capital T's is equal to, we find here there is just one repetition, and that is T. T is repeated twice. So where here we can write it is 2, and rest of the the rest of the letters are occurring only once. And how many vowels we find here? Number of vowels is equal to, how many vowels do we get here? Let us check. This is one vowel, second vowel, third one, fourth one, fifth one. So all the 5 vowels are occurring here. So number of vowels is equal to 5 here. So after this, Coming to the first part of this question. So in the first part of this question, let us first check what the question says. The words start with P and end with S. That means first position, since there are 12 letters, of course any word that we construct with these 12 letters will be containing 12 positions. So amongst these 12 positions, it is very clear that the first position should always be fixed for capital P and the last position should always be fixed for capital S. So while writing the solution, we shall be writing, since the words start with capital P and end with capital S, therefore P and S remain fixed in the first and the last place. In the first and the last place. Therefore, remaining number of places is equal to, what do we get? 12 minus 2, it is of course 10. So these 10 places we are to fill in with the remaining letters. So in this case, required number of arrangements, or you can say permutations, will be equal to 10 factorial, as only 10 letters are there to be for arranging this letters of these words, divided by there is repetition with the letter T only. That means T is occurring twice and the rest of the letters are all different. Therefore, in the denominator part we have to write 2 factorial. So let us break it. 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2. If we do not write 1, then also there is no problem. So after this we can write 2 factorial. Let us keep 2 factorial with this part. 2 factorial here, 2 factorial gets cancelled. Multiplying the rest of the terms, we shall be getting the result 1814400. So this is the total number of arrangements for the first question. Coming to the second question. This is the second question. What it says, vowels are all together. When the vowels are kept together, we already found that there are total of 5 vowels. Here number of vowels is equal to 5. When these vowels occur together, then these are together considered as one letter. Therefore, total number of letters total number of letters become, in total we had 12 number of letters, yes or no? In total we had 12 number of letters, and out of this we are getting 5 vowels. So if we consider this as single letter, so of course we have to subtract 5 from 12 and again add 1. So it will be 12 minus 5, the result will be 7. With 7, this single letter I have to add, and that will become 8. So here I find 8 number of letters in total. Again, most importantly, these 5 vowels, what I mean to say is, these 5 vowels A, E, I, O, U, all these 5 vowels are occurring individually. I mean, there is no repetition of these letters. Therefore, for each one, actually each of these letters can occur in 1 factorial ways. 1 factorial ways. So in total there is no repetition. So in what way these vowels can be arranged? Following the second theorem, I can write like this: 5 factorial, this is the total number of vowels, divided by 1 factorial, 1 factorial. It will continue up to the 5th term. I mean, in the denominator part, 5 times, I mean 5 1 factorials I need to write. So coming to this solution part again, we shall be getting, that is what I am going to write here. Again, these 5 vowels can be arranged in 5 factorial ways. So after this we can write, actually we need to find out total number of permutations. So here goes the result. Therefore, the required number of arrangements when all the vowels are, or you can say occur together. It is better to write occur together. It is occur together will be equal to, I shall have to write here 8 factorial, because that is the total number of letters left, including this 5 vowels as 1 letter, and there we already got that there is repetition with the letter T only. So in the denominator part we need to write 2 factorial, and again by principle of fundamental principle of multiplication, I have to multiply this term 5 factorial with it, because we have to consider the arrangement of the vowels also. So after complete cancellation and all, reduction, we shall be getting 8 into let us break it up, 8 into 7 into 6 into 5 into 4 into 3 into 2 factorial divided by 2 factorial into 5 factorial. 2 factorial gets cancelled, and then after we have to break it once again. 8 into 7 into 6 into 5 into 4 into 3 into this 5 factorial will have to be broken further. 5 into 4 into 3 into 2 into 1. After complete breaking, the result will come as 2419200. This is the complete calculation for this second question. This is the answer for the second question. Coming to the last part of this question, what is said? There should always be 4 letters in between P and S. Here I'm going to write here, there should always be 4 letters between capital P and capital S. The possible places, this is I'm writing just for your better understanding, please try to follow. Possible places of P and S are, means I mean to say, when P is placed in the first position, S should be kept in the sixth position, then only there will be 4 places in between. Similarly, when P is placed in the second position, then S should be placed in the 7th position, then only there will be 4 places in between. Similarly, when P is in the third place, of course S should be there in the 8th place. When P is in the 4th place, then S should always be in the 9th place, then only there will be 4 places, 4 letters in between, 4 positions will be left in between 4th place and the 9th place. In total we are having 12 places, because 12 letters were there given. Then when it is kept in the 5th position, here it should be 10th, S should be in the 10th position. When it is kept in the 6th position, it should of course be placed in the 11th position. S should be placed in the 11th position when P is kept in the 6th position. Similarly, when P is kept in the 7th position, S should be kept in the 12th position. So that is the ultimate position, means 12th position is the last position. So how many such options we are getting? 1, 2, 3, 4, 5, 6, 7. This means when P comes first and S comes later, we are finding 7 such positions. 1, 2, 3, 4, 5, 6, 7. If the places are reversed, suppose S comes to the first place, S is written before and P is written after. I mean to say, when the positions of P and S are interchanged, then similarly another 7 positions I am going to get here. So in total there are 14 possible cases when the places of P and S are interchanged. So all these 14 places we have to take into account, means these 14 ways P and S can be arranged to keep 4 letters in between them. So here we can write interchanging the places of P and S in total. The number of permutations obtained, or you can say number of arrangements. It is better to write arrangements here, because that will sound good in the final answer only. Total number of arrangements obtained is equal to 2 into 7, means 7. First 7 is for direct arrangement when P is kept initially, then after S, with 4 places in between. And the second 7 is for interchanging the places of P and S. So in total we get 14 places. So remaining number of places, the remaining number of places, why did I write this? Remaining number of places, why did I write so? Because it is very clear that P and S, for P and S the positions are already fixed. Amongst these 12 positions, 2 positions P and S, 2 positions will always be there for P and S. So how many places will be left behind? Of course 12 minus 2, there will be 10 places left behind. So after this, these 10 places. It is now time to calculate in how many ways then these 10 places can be filled in. These 10 places can be filled in how many ways? 10 factorial ways, of course. That should be again distinct. And in what way this can be made distinct? Dividing this by 2 factorial. This 2 factorial is for what? Repetition of the letter T. Therefore, total number of permutations this will be equal to 10 factorial divided by 2 factorial into this 14 I have to take into account for specification. This should be more distinct because we have to consider the case where there should be 4 letters in between P and S. So after reducing this calculation, we have to perform 10 into 9 into 8 into 7 into 6 into 5 into, then after 4 into 3 into, let's write it 2 factorial divided by 2 factorial into 14. Then 2 factorial gets cancelled, and after complete multiplication the result comes as 25401600, and that is the answer for the third part also. And with this question the exercise 7.3 gets over. Thank you.